Hello and good morning, everybody. Happy Monday. I hope you had a great weekend. Welcome to math. Here's our teaching point for the day. We're talking about magical multiplication tables. I know, incredible. Our I cans are below. There's one of them today. It says, I can use a multiplication table to find equivalents for a given fraction. We've been talking a lot about fractions and the important skill of finding what we call equivalent fractions, or fractions that have the same value as other fractions. 1/2 versus 2/4 versus 3/6. Okay, you're cutting each piece into smaller equal pieces, but the value of them is the same. You'd find them in the exact same place on a number line. There are your materials. You're going to need something to write on, something to write with, and then that one right there at the bottom, that's our new one, a multiplication table of some kind in order to successfully do the exit ticket. Now, there are some of you, and this was true for everybody in the 4th grade, if you had a name tag, here's Jesleah, Lily's, and Fiona's, shouts to you, you had, that's on this side, you had a multiplication table right there on your table and at your desk at all times. How handy was that? Here's the problem with the distance learning. Not the only problem, but that's a story for another day. Here's one of the issues with distance learning is unless you had the foresight to get a book bag from me and I threw the name tag in there with it, you might not have a multiplication table at home. Thankfully, you have a couple of options. You can use the one that is linked on the virtual classroom. If you find and click the calculator, then you can get to an interactive multiplication table that you can click through and use with your mouse, and that enables you to use a multiplication table even when you don't have one in front of you. Your other option is you can make your own. This took me about 10 minutes, I would say, because I was writing big and because the 11s and 12s are hard. But what you can do, take a big piece of paper, and the nice thing is if you take a little bit of time and make it really, really neat, spend a little bit of extra time on it up front, you can continue to reuse it and reuse it and reuse it. So I put it on a big piece of poster paper here. I put 1 through 12 at the top. I put 1 through 12 on the side, and then where each of them meet, I put the product of those two factors. So 1 times 1 is 1, 1 times 2 is 2, 1 times 3 is 3, and so on. So if I want to find, say, 7 times 8, I can go to the 7s, and I can go to the 8s, and I can see where they meet up, and they meet up at, you can't see it, but there it is under my elbow, 56. So I can quickly find that 7 times 8 is 56. And making a multiplication table like this, it's a sneaky way to have you practice your multiplication facts. How about that, right? You could go just to 10 times 10 if you wanted to. You could go to 12 times 12 if you wanted to. Heck, you could go, if you were feeling up to it, all the way to 15 times 15. I bet you haven't practiced your multiples of 14 in a long time. Might be a good idea if you were feeling comfortable on the smaller ones. If you really just want 10 times 10, do it. Okay? I happen to think 12 times 12 is kind of the sweet spot, right? Anything above 12 times 12, and we can just use one of our given strategies or a mental math strategy to calculate those. But inside 12 times 12, it's nice to have those automatic so you don't have to think about it when you're doing a bigger multiplication problem or you're doing a fractions problem. Okay? Knowing right off the top of your head that 6 times 7 is 42 can be very helpful in this case. So here I have our multiplication table, but how does it help me? How does it help me find equivalent fractions? What you can do is this. Let's say I have, been liking fifths lately. Let's try 2/5. Now, if we remember using our multiplication equivalence of 1, and reminder, some examples of equivalence of 1, 2/2, 3/3, 4/4, etc. Anytime you have the same numerator and denominator, that equals 1. 1. So by multiplying by an equivalent of 1, we're not changing the value, because when you multiply something times 1, it just equals itself. 6 times 1 is 6. 1,000,000 times 1 is 1,000,000. Okay? So we can multiply by any one of these and get an equivalent fraction to 2/5. Why is the multiplication table helpful? Well, it has all of our multiples right there. 2 times 2 times 3 times 4 times 5, and so on. So what I can do, I would recommend grabbing something flat or straight. Okay? Doesn't have to be a name tag. It can be, I have an old sentence strip here I could use. I have a piece of black paper I could use. I have the straight end of a protractor, though that's see-through, so it's a little bit maybe not as great. I have there's a cardboard box over there I could use. There's the end of a book. Lots of flat, straight things to help you see that row or see that column. So first thing I'm going to do is, and in our exit ticket, we're going to do this. You're going to give 5 different equivalents of 1. Seems like a lot until you get to the multiplication table. So let's see here. Let's going to start with our 2. We're in our 2's row. And let's take a look at if we take our 2 and we multiply it by 2, right? We're going to get 4. Then we take our 5's row, multiply it by 2. 5 times 2 is 10. Okay? And essentially what we've done here is we have multiplied 2/5 times 2 over 2. 2 times 2 is 4. 5 times 2 is 10. So we know this is an equivalent of 1. An even faster way, if you wanted to go in order, is you could just go straight down the row. So what comes after 4 in the 2's row? 6. What comes after 6? 8. What comes after 8? 10. Okay? And then let's go to the 5's to get our denominators. What comes after 5? Or excuse me, what comes after 10 in the 5's row? That would be 15. What comes after 15? 20. What comes after 20? 25. Okay, and you'll see here, each of these line up. So 4 to 10, 6 to 15, 8 to 20, 10 to 25. Okay, if you wanted to keep going, you could keep going with 12 30ths, 14 35ths, and so on. All right, all this is doing is essentially showing us, all we're doing is we're moving across multiplying. Okay, and with our multiplication table, as long as we're keeping our columns lined up, so keeping 4 tenths, 6 15ths, 8 20ths, 10 25ths, and so on, this is kind of our shortcut. Some of you that we're finding multiplication to get equivalent fractions a little challenging might be thinking to yourself, Mr. Taco, why didn't we just start with this? This seems way easier. Correct. The reason for that is we want to build that conceptual understanding of what we are doing when we make equivalent fractions. Otherwise, we could just be making it and not understand why. Okay, so it's important to have both, right? If we had just started with this, and I just told you just use this multiplication table, then anytime you'd have to find equivalent fractions, you'd have to go, oh no, I'm at the grocery store and I need to figure out equivalent fractions for this recipe. I got to go home and get a multiplication table and then go back to the store, right? So we start with the concept of multiplying by 1 or multiplying by an equivalent of 1 and how that doesn't change the value of our stuff. Okay, if you have a pizza, you cut it in half, and you essentially multiplied it by 2 halves, and you have 2 halves, right? Take your 2 halves, multiply that by 2 halves by cutting each piece in half, okay? You're not changing the amount of pizza that you have, you're just cutting it into smaller pieces. And that's all we're doing when we multiply by equivalents of 1, okay? When we start multiplying by other fractions that aren't 1, it does change the value, just like multiplying by any whole number that's not 1 changes the value. But we'll get to that later. For now, using our multiplication table, you can find any equivalent fraction. Well, as provided that you go up to twelfths or to twelfths. If you only had a 10 by 10 multiplication table, you could use it to find anything up to 10 tenths, right? Let's try one more before we go to our digital whiteboard. Let's use 4 sixths. I know that is not a simplified fraction, but I do want to get us into the habit of using all of the columns here. So let's take a look, find our 4 and our 6. So here's our 4s, here's our 6s, and they're kind of close together, so we can actually kind of see them. So 4 sixths, what would be the next one? 8 twelfths. Then move to the next row, 12 eighteenths. Okay, the key is, and this is why I recommend using a straight edge like this, is to make sure that we're staying in the right column or the right row. If we get kind of diagonal, that's where things can get off, right? So if 12 eighteenths, move 1 over, 16 24ths. And let's do one more for good measure, 20 30ths. Whoops, 20 30ths. Okay? Remember, if you don't have a multiplication table at home, you've got 2 options. You can use the one that's on the virtual classroom. If you find and click the calculator, it's on my desk. Or make your own. Often, this is the best way to do it because you end up practicing your multiplication facts along the way. Let's go to our digital whiteboard and try a couple. All right, so we've got 7 tenths, and I'm actually going to move, let's see if I can do this here. Yeah. All right, so now we've got, it's pretty small, but maybe I'll move back to the full screen when we need it. So we've got 7 tenths, okay? So we need to think about our equivalents for 7 tenths. Okay, the other thing you can do, remember, our multiplication table works because essentially all we're doing is we're using repeated addition, right? For our 2's, it's just 2 plus 2 plus 2 plus 2 plus 2 plus 2 plus 2. That's all multiplication is, just repeated addition. 3's, we're counting by 3's. 3 plus 3 plus 3 plus 3 plus 3 plus 3 till the cows come home. So for 7 tenths, even if you didn't have a whiteboard in front of you, or a whiteboard, even if you didn't have a multiplication table in front of you, you could simply count by 7's on the top, count by 10's on the bottom. You could, okay? But let's use, I'm sorry, I'm switching back and forth, I know, between all these cameras. So let's look at our 7's here. We've got 7, and here's our 7 tenths. So looking at these 2, oh, perfect. Oh, look at that. Huh! We did it. You can see the 7's above and the tenths below. It's almost like this is just one big sort of line in the middle of our fraction here. So we've got 7 tenths. What comes next? 14 20ths. Then what? 21 30ths. And so on and so on. What's the next one? Take a look. Here we were at 21 30ths. What comes next? Yeah, 28 over 40. And then 35 over 50. So we can go ahead and use our whiteboard digital and write it in here. 14 20ths. And really, we can just count, right? 10, 20, 30, 40, 50, 60. And then count by 7. 7, 14, 21, 28, 35, and then 35 plus 7 is 42. All right. Pretty simple once we get into the pattern. Let's try this one. Aha, 2/3. Okay, again, either use your multiplication table, or you could theoretically just count by 2's on top, count by 3's on the bottom. Okay, and look, we've kind of got it right here, right? 2/3, 4/6, 6/9, 8/12, so on till the cows come home. Makes sense here? And I want us to notice something about, as I write it in here on the digital whiteboard, I want us to note something about this particular fraction, this particular string of equivalent fractions. 10/15, 12/18. Okay, so I'm going to write this on our in real life whiteboard because I want us to see something here. Sixths, 6/9, 8/12, 10/15, 12/18. We're going to go back full cam here for a second, because I want us to take a look at those two strings. We've got 4/6 equivalent on the top, 2/3 equivalent on the bottom. You notice anything interesting? Because I do. Here's 4/6 and 4/6. Any other common ones? Yeah. 8/12 and 8/12. And then 12/8, oh boy, we're going to have to go around the bend here. 12/18 and 12/18. Right? So, noticing that 4/6 simplified is equivalent to 2/3, we end up with these two strings that really are equivalent fractions, but because we're starting at 4/6 and getting doubled every time, or adding 4 to the numerator, adding 6 to the denominator, it ends up being skipping a term in our 2/3, because our 2/3 are only adding 2's and 3's versus 4's and 6's. Fascinating. Okay, everybody. For the exit tickets today, you're going to need a multiplication table. I would encourage you to make your own, like I made my own. Again, mine took about 10 minutes, depending on how neat you make it and how automatic you are with your multiplication facts. It might take you a little bit longer, and that's okay. And then go ahead and use that exit ticket. We're going to be doing the same thing, essentially the same thing we've been doing during this lesson, as finding the next 5 terms for any given fraction, right? So just one more refresher. So starting here on our multiplication table, whatever our numerator is, find the next 5 terms. Whatever our denominator is, find the next 5 terms. Okay? If you get fancy and skip some, you can, but you've got to keep our columns lined up. So if you're skipping, if your fraction is 2/3 and you want to skip one, you have to remember to keep them lined up. You don't want to get off, because then that's no longer an equivalent fraction. Okay, so if you wanted to skip them and go 2/3 straight to 6/9, straight to 10/15, straight to 14/21, you could, but just be careful and stay lined up. All right, everybody, thank you for tuning in. I appreciate the attention on a Monday. The secret word today is going to be Shrek. It's going to be Shrek. Stay out of his swamp. Do your exit ticket. We will see you in the Zoom room if you are so inclined and want some more feedback and support. That starts at 11 o'clock. Otherwise, we will see you back here on YouTube at 1:15 for today's science lesson. Take care and cheers, everybody. Good luck.